Alright, welcome to 7.2. We're dealing more with the standard normal distribution. Distribution, for those who may have forgotten or have never heard that word before, just means how things are mapped out. So what's really happening, how's the data looking, we get a distribution. We talked about the normal curve last time, right? Just a refresher real fast. We ended with this problem. We had the scores, the average MPGs for a car. We had a mean of 22 miles per gallon. We had them all the way up to 34 and down to 10. We did that by adding 4 to the standard deviation, right? We went both ways. And then we found probabilities based on all of the data that we found. Talking a little bit more about the mean and the standard deviation, we kind of mentioned this with the tests as well at the very beginning of the last video. If you have, so all of the 3 of the graphs you see have the same mean. They have a mean of 3. Whatever the mean that's talking about, they all have the same mean, right? But the standard deviations are different here. The one that has a bigger standard deviation, you can see it's a lot more spread out. This is the test that was all over the place. You know, you had a bunch of people getting C's and a bunch of people getting A's instead of everybody getting, B's, right? Or, you get C's, D's, whatever. But then if you had like smaller standard deviations, you get something like this, where the whole class actually did get a B- on the test. And there weren't that many people who were outside. So your standard deviation can affect your normal curve a lot. And it can actually help you make some statements about some stuff. But standard deviation is also super powerful for finding probabilities. Last time, we were set with very strict standard deviations. We could only go up 4. We could only go up $700. We could only go up 7. We can only go up, what was the first one? Standard deviation of 3 inches, right? But what about somebody who doesn't hit one of these lines? How do you find the probability when, let's take, for example, this last one. What was the probability if someone's car had 27 miles per gallon? Right? With the normal curve just as it is, you can't do that. You had to get exactly 26 or exactly 30. And that's kind of a problem because somewhere in there is 27. But it's not exactly, certain increments. We can't just say split this up into 4 pieces because it doesn't, it's curving, right? There's going to be more people in this first part than there is in that second part. As you can see, the line is starting to go down. So how do we figure out all those other people who don't exactly fit our standard deviations? That is where this formula on the next page comes in. It's called a Z formula. Go ahead and give it a very large box. Okay. This is the Z formula. Now, this can help you calculate exactly where the line would be for a non-standard standard deviation. So that 27, right? That's not one of the ones that is on our standard deviation line. So I can use this formula to figure out what the Z-score is, okay? So let's kind of calculate a couple Z-scores, and then we'll figure out what that actually means. Like, how is this helping us, okay? This formula looks like this. X minus mu over sigma. Do not mix it up. It's not mu minus x. In other words, it's the value in question. So value minus average. I'm going to write this so you can read it. Average over your standard deviation. Okay? So I take the value in question, the 27, minus my average of 22, and then divide it by that standard deviation of 4. It's going to give me a number. That number should, if you've done this right, you really want to watch out for this, it should be between -3 and 3. Okay, that's what we're shooting for. If it's outside of that, chances are either you did something wrong because you calculated it wrong, or what you're trying to find makes no sense for the problem. If it's outside of -3 to 3, you're probably not making much sense in the problem. If, for example, what is the miles per gallon or what is the probability you get a miles per gallon that's 100? Well, that one's going to be outside of 3 because almost everybody else is within the 20s, right? That one doesn't make sense. So the only reason you'd get outside of these 3 zones is you're trying to do something crazy or you've done some calculation wrong. But let's go ahead and find some now. So example number 1. Consider an exam that has a normal distribution of scores. If the mean score is 75 with a standard deviation of 6, find the z-scores of the following exam results and then draw the curve. So let's just find the z-scores here. We'll calculate them out. We'll use that formula. So these are all of our x's, right? They're the same x probability from last time. The probability that x is blah, blah, blah for 84. We don't have a probability, but it's the same x. Okay, so let's find the z-score for 84. We take 84, our value, minus our mean, our average here was 75, divided by our sigma, our standard deviation was 6, and we can go plug that in the calculator. Do the top first. Just go in the same order, okay? 84 minus 75, we get 9 over 6. So divided by 6, we get 1.5. Our z-score is 1.5. Awesome. All right, cool. So what the crap does that mean? We'll go over here, we'll draw a quick normal curve based off this information. For this purpose, I'm going to leave out the 34, 34, 13, 13, 2.51 from last time. I'm just going to fill in the means on the bottom. I'm sorry, the information on the bottom. We had 75, and then 6 up from that, I believe is 81. 6 up from that's 87. 6 up from that would be 93. Okay. And then we go down from 6, 69, 63, and 57. Okay, so this is what our normal curve is. Obviously 84 is not on here, right? But 84 is somewhere right here. We could maybe say like here, kind of in the middle. In fact, I don't even have to say kinda. What my z-score just showed me is this is 1.5 standard deviations away from the mean. That's this space right here. Here's my mean. It's not 1, because 1 is 81. I'm going to use different colors so you can see. Here's my mean. I'm going my 1 to 81, and then another 0.5 to 84. So that's what z-score is. Z-score is how far away from the standard deviation are you? From the mean are you? It's showing you those non-standard standard deviations. Does that help me with the probability? I'll show you how in a minute. But that's what we're finding. Okay, so we're finding how far away is this score. Is it really weird, or is it just kind of normal, right? In this case, you can make that claim. All right, let's do it again. Let's do it with blue this time. Purple. We'll do purple. So z for 70 would be that value. Take away the mean, divide by the standard deviation. And we get negative 5 over 6, which is about negative 0.8. And then it goes into a bunch of 3s. We're going to round to 2 decimal places, okay? 8.3. We're always going to round to 2 decimal places. And yeah, rounding is going to be a big deal here, so make sure you round correctly. All right, so where is that? Negative 0.83. Well, that means we're going down, right? So we're going to go back, not an entire 1, but really close to 1. And that does make sense because 70 is right close to 69, which is one of our marks. And so we're really close going back that 0.83%. Oh, sorry, 8.83%, right? Okay, one more. Standard deviation here. So we'll get a z-score, 87 minus 75 over 6. Let's see, 87 minus 75, we get a 12 over 6, a nice even 2. That actually tells me something. The fact that that's an even number, check it out. 87 was already on our curve, right? Is right here. He's exactly 2 away. That makes sense, right? So that even the z-score formula is going to spit out those same normal ones as well, right? Those ones that the normal curve would have given us anyway. But it is exactly 2 back. That matches with its z-score. So now you kind of know what a z-score is, right? How does this help us find the probabilities? It does. It does actually help us find the probabilities. Unfortunately, the calculation for that is incredibly immense. So what we have done, I did not do this because it takes hours upon days upon weeks. But what some statisticians have done is given you what we call a z-table. We're going to use that in the next problem. Go ahead and find your z-table now. It should be attached to the very back page of your chapter notes. If you go all the way down, you will find, oh my goodness, this packet is long. Oh, no. Ah, sorry. I did that thing where it zoomed out. Let's go like this. There we are. Okay. Go all the way down, you will find the z-tables. Like I said, it usually goes between -3 and 3. But check these out. They're on page 27 and 28. 28 also has something we're going to use in a later chapter, so don't cross it out or anything. But since it's kind of immense, we're going to look at these first. So a z-table, you've got a negative side and you've got a positive side. That 1.5 that we found, we'd go over here and find 1.5. The -0.83 we found, we go over here and find -0.83. I'm going to show you exactly how to do that in the next problem. Okay, so let's go back now. Too far. We are here. Page 9 again. All right. Okay, problem number 2. The starting salaries of college graduates at a local university are normally distributed with a mean of $48,000 and a standard deviation of $6,000. What is the probability that a graduating student from this university chosen at random has a starting salary of blah, blah, blah? Okay, so it's very similar to the last problem, right? We don't we have information about the standard mean, or the mean and the standard deviation, so we can start with a normal curve. When we do that, we would find that not a lot of these numbers are going to be on that normal curve. So why don't we just jump to the z-scores? Let's jump to the z-scores. What would be a z-score for 38,000? How many standard deviations is 38,000 away from 48,000? No, the answer is not 10. Okay, but let's go ahead and plug in that formula. So value, 38,000, minus mean over sigma. Careful not to mix those first two up. I know it's tempting to go the other way. But remember, 38,000 is less than, so this should end up being less than. This should be a negative number. It's less than the mean. So I plug that in. We get, no, just kidding. 38 minus 48 divided by 6. We get negative 1.67. Remember, we're going to round to 2 decimal places. Technically, we get 1.6666666, but we would round that second one up to 7, right? 5 and above, you round up. 4 and below, you let it go. Okay. Well, that's all fine and dandy, but that's not a probability, right? That's just a number. We know that if we're looking at a normal curve like this, we're seeing it back 1.67. Here's where the z-table comes in. For ease of shuffling, I have grabbed a new z-table. So I'm over here on my z-table now. You can just turn back to yours on page 26. Remember, we have a negative and a positive side. So let's go look at the negative side. Remember, our z-score was negative 1.67. Oh, heck. Stop that. I'm not trying to rename it. Oh, excuse me. Excuse me. Okay, so negative 1.67. How does this table work? Instead of listing every value from 0 back to negative 3.349 and then the same up, what they've done is kind of broken off that last number. So we're going to look for negative 1.6 and 0.07. Okay, so that's what they've broken it up that way. So if I go look for negative 1.6, it's right there. Yeah, so all of these numbers are the 0.6 numbers, negative 1.6 numbers. I'm going to kind of shuffle over to 7, and I'm going to find where the two meet. Right about there. So we get 0.0475. In other words, what somebody has found is that if you go back that far and you add up the value to there, you get 4.75%. And so they've basically done the adding part for us. Go back to our notes now. We can just write that down. This translates to a probability x is less than 38,000, that 4.75%. And that's it. That's it. They've basically done that work for us with the z-table. Okay, what is the probability someone is less than 63,000? Well, that one's bigger, so we're looking at a positive number, right? Because it's bigger than the mean. But let's go ahead and see what positive number. Z equals 63,000 minus 48,000 all over the 6,000 standard deviation. Plug that in. You get 2.50. And yeah, we still want to take that to do 2 decimal places. I know it seems silly, but 2.50 is better than just 2.5. But that's a z-score, right? So we're back we're forward 2.5 standard deviations. Let's go check out our table. Okay, negative side's not going to help me. Let's go to the positive side now. Don't know what this line thing is, but okay. Oh, it's just the bar. So positive 2.5 is here. 0 is there. Now we see why we wanted to keep that 0, so we knew which bar or which column to go to. Their matchup right there. 99.379. In other words, 99.4%. You can round to where, like, a couple decimal places is fine. All right. 99. So notice I'm not writing an equal sign because 2.5 doesn't equal that, right? But 2.5 tells us that the probability of x being less than 63,000 is equal to 99.4%. Cool. If you have any questions, you can call the sub over, but once again, we don't really want to stop these videos. If we do, we tend to run out of time. So you can just jot a note down, say, hey, I need to ask about this. You may even see them pop up in the rest of the video. But, do get your questions answered. Okay. All right, let's look at another one. Between 4,320 and 54,000. What could that be? Okay, well, we can make a z-score for both. Let's see exactly what we're looking at here. We kind of had a between last time when we found the in-between stuff, right? Kind of a big note about z-score, though. Notice the first two were just less than. There wasn't even an option for greater than. There was no like, hey, here's a z-table if you're looking for greater than, and here's a z-table if you're looking for less than, and here's a z-table if you're looking between. Z-scores only work less than. They only show, I should say not work, but they only show less than, and that's a huge point. They've only added up the values for less than. So if we're over here, and I'm looking at that negative 0.83, this is what the z-table is showing me. If I'm looking at that positive 1.5, this is what the z-table is showing me. I am going to have to make small calculations to kind of get which sections I want. Z-scores only show less than. Okay, they only show less than. So how does that help us with this between problem? Well, let's at least kind of get the picture, right? Let's get the z-scores. Let's see what they're saying. One is obviously going to be less than the mean, so it's going to be a negative number. The other one is going to be greater than the mean, so it's a greater than number. Not a guarantee, but I can see that here. So let's go ahead and get those z-scores. Oops. Minus the 48 over 6,000. We get 40320 minus 48000 divided by 6000. Negative 1.28. Yeah, okay. You say so. All right, and then the other one. We can do like Z1 and Z2. Makes you feel more comfortable. 54, 1, 2, 3, minus 48, 1, 2, 3, over 6, 1, 2, 3 zeros. 54 minus 48 divided by 6. I think we get 1. Yeah, we get exactly 1. That's cool. That means it's actually a standard deviation line. I don't know how that helps me in between right now because I have another one that's not just a between, so I'm still going to need to find those. Okay, how does this help me with between? Well, if I find the percents for both of these, maybe that will show me something. Save just a little bit of room here for a sketch of a normal curve. We're not going to draw in the whole thing, but let's go find those probabilities. Go back to our z-table. I wouldn't recommend actually writing on this thing because you're going to use it a lot. So we need a negative 2.8 or 1.28. So here's 1.2. Here's 8. I'm going to meet up at, looks like about 10.03%. Okay, let's go back now and write that down. Oops. So this one was 10.03%. And then a 1, we're going to get pretty close. Now, we kind of had this conversation last time, how our lines are the best case scenario. You're going to see in your z-table that it's not going to be like 84 or 68 or something that's, you know, what we're used to. Let's go ahead and go to 1.0, 1.00, and we get 84.113. 84.13. It's close to 84. Okay, so now what does this mean? Does this mean I add the 2? Do I subtract the 2? Well, let's look at the normal curve for that. So here's our 1 standard deviation away, right? This is the 84. There's that 84. The other one, change colors. Here's our 10, right here, or sorry, here's our negative back 1.2, 8, 1.3-ish. Here's that 10%. Where would the between these guys be? That would be the just yellow colored zone, right? If I have the double zone, those guys are less than. The z-score is always working less than, so that 10.03 is all the pink. It's the less than that mark. Those are the people I don't want. I don't want those people. They're not between. They're outside. They're less than 40,000. So I'm going to take out that 10%. So basically, I'm going to end up doing 84.13 minus 10.03. And we get that the yellow only zone is 74.1%. And those are the people in between. So while z-score is fabulous for less than, we do need to adjust it a little bit for anything that's not just less than. All right, cool. Kind of the same question with the last one. We have greater than. We know z-scores don't work in greater than, but we can apply kind of the same logic from last section. If we had less than, well, together they got to be 100. So let's go ahead and find less than. Let's find less than 41,000. And then we can adjust it to be greater than. So the z-score for that would be 41,000 minus 48,000. Oh, it's going to be negative over the 6,000. We get negative 1.7. I'm sorry, 1.17. 1.17, okay. Our z table will now tell us that that is see, that's positive. Here's negative. Okay, we'll zoom in. Here's 1.1. Over here we see 0.7. They match up. Very convenient that they've colored these like alternating colors, because then I can just follow that gray line all the way back to 7. And we're looking at 12.1%. Okay. Cool beans. So that's 12.1%. But that's less than, right? We don't want that. We want it greater than. So 100% minus 12.1%, 87.9%. That would be our greater than. Okay. Oh, I should put an arrow because those don't equal. And you're going to find that balance a lot. Still a heck of a lot better than having to add that up on our own, right? Finding 87.9 as opposed to 88, annoying. So z-table is very helpful. All right, let's do one more. Okay, the ACT scores by student in a local district are normally distributed with a mean of 21 and a standard deviation of 5. What is the probability that a student chosen at random receives a test score ABCD below 25? Okay, now I could draw a curve. It might be one of the lines, but a z-score is going to tell me that too. So why don't we just start with a z-score? This is another one of those problems that I recommend you pause the video, give it a shot on your own. Don't take too much time because we don't want to have the video go over, or over time for the class. But go ahead and pause, try it out, maybe do A through E. When you guys feel ready, turn the video back on. Okay, hope you had a chance to pause the video and give it a shot. If you decided not to, that's up to you. Okay, so we have a z-score for 25. We take 25, we minus the mean of 21 over the standard deviation of 5. We get 4 over 5. Oh my heck. 0.8. Okay, so we get 0.8. The z-score for that, go to our table. I'm sorry, that is the z-score, pardon me. The probability for that, let me clean this up. Okay, it was positive 0.8. Yes, so we will go to 0.80. 78.81%. It's a probability of 78.81%. Cool, cool. All right, greater than 18. See a z-score for that. 18 minus the 21. Going to be a negative z-score because it's higher than the mean. I'm sorry, lower than the mean. Negative 0.60. Okay, I really should have put a 0 on that. That transfers, I did it a little ahead of time, to a z-score of 72.57%. But since that, oops, pardon me, hold on. I want to double check something before I write that down. Let's go look, because negative should be less than 50. So I'm thinking I already finished that problem now. Let's go to negative 0.60. Yep, see we get 27.43. 27.43%. So then where on earth did my key get this 72? Oh, right, it's greater than. Greater than 18 means I have to take it away from 100, because this is showing me less than. I want to make sure I did that right. Yep, and that's where I'm getting the 72.57% for greater than. All right, between 14 and 30%. Well, I'm gonna need a z-score for both. So a z-score for 14 would look like that. Yeah, negative 1.4. Since I don't like flipping back and forth a whole bunch, especially on my iPad/phone, I'm gonna do both z-scores and then go find both percents. Totally up to you. The second z-score would be 30 minus 21 over 5. That's just 21. 9 over 5, 1.8. Okay, those two z-scores give us probabilities of 8.8%, which makes sense, right? If we're below the mean, it should be below 50%. For above the mean, we should have higher than 50%. We actually get, I don't know if I did that right. Hold on, I'll double check. 1.80. Yep, look at that. I was shocked by my own value, but it is 96.4%. It's amazing how fast that normal curve drops, right? 96.41%. Now, between, just saw this, we're back to the orange zone only idea, so I want to take these two away. 88.33%. So these are the people that fall into the less than 30, but the 8.8, because those are less than 14, we took them out because they're too small. So we are left with 88.33 people. No, I'm sorry, 33%. All right, what approximate test score would put a student in the top 5%? This is a different type of question, isn't it? But same idea. What would put a student in the top 5%? Well, what does that mean? What does that even mean? It means this score is greater than 95% of people. So what score is greater than 95% of people is the first question, or is actually the question. So what is X? What is X? They've given me X up to this point. Well, I know the answer to the last three problems instead of the question to the last three problems, so let's go ahead and just flip this idea on its head. 0.95 was given to us by some z-score. So let's go see if we can find that z-score. What is the z-score that would have given us 95, right? That's the question. What is the z-score there? Instead of looking on the sides, let's look inside. Let's look in at the probabilities. Let's see, there's 91, too small. There's 95.5, Let's see, over on the other side, we have 95, 95, 95, getting closer. 95, oh, and now we're down to 4.5. So, let's see, which one should we go with? Should we go with 0.95035 or 0.4950? Which one is actually closer to 95? The first one is 0.00053 off. The second one, whoops, I want to make sure I get these numbers exactly right. The second one is 0.0005 off. So really, since, I mean, at the end of the day, is it going to be that big of a difference? Probably not. But we need a different z-score, so it might be a little, it might change a bunch of our answers. I think the bottom one is just slightly closer because he doesn't have that 0.003. So we're going to go with the bottom one. If you went with the top one, I'm going to be honest with you, it probably wouldn't make that big a difference. But we're going to go with the bottom one here. 94.95. Now, what on earth would give us that? It looks like a 0.164. A 0.164 is what's going to give us that z-score, that probability, right? Okay, 0.164. So let's go ahead. 1.64. Go back here. That was so the 95% was created close as possible by 1.64. Alrighty, so what does that mean? Well, that means we got that from x minus mu, well, mu we knew a mean of 21 over a standard deviation, also we know 5. Now we have an equation. Okay, so I'm literally just going backwards here. I am just taking a probability I would have gotten from the z-table, and I'm finding the z-score instead. And then I'm plugging that into the z part of my equation, and I'm leaving the value that we usually plug in blank. So I'm literally just going backwards. All right, let's see if we can solve this now. Oh, harder to solve, right? I don't like this fraction. Let's get rid of it. Times 5. So over here, 1.64 times 5, 8.2 equals x minus 21. Add 21 to the other side, 29.2. 29.2 is the score, and we don't know how this test is scored, so maybe you can get a 0.2, is the score that would put you in the top 5%. That would put you at the top 5%. Obviously above that score, you'd probably be still in the top 5%, but you'd be in the 3% or something like that. All right, cool. Let's try another one. What would put a student, or what test score would put a student in the lowest 33%? All right, no conversion here between 5 and 95, just straight up 33%. So 0.33. Let's go see what z-score does that. Looking ahead of time, we'll go do it together. We got time. Okay, going back to the negative side now, because the reason I'm looking on the negative, I kind of know it's negative is because it's less than 50, right? 50 would be the mean. Anything less than that would be on the negative side. Anything bigger than that would be on the positive side. So I'm going to go search around. 3, kind of seeing some 3 3s. Kind of like here. Hey, look at that. They even have exactly 0.33. That's awesome. Okay, we have that one. It looks like a z-score of negative 0.44, right? So just connect those two things together. Go back here. So that translates to a z-score. Let's use an arrow instead. To negative 0.44 z-score. And that's going to equal x minus 21 over 5. Same information, same other half of the equation. All right, start solving that now. Times by 5. We get negative 2.2. Add 21 to that. We get 18.8. That makes sense. 18.8 would put you in the lowest third of the class. Good to know, good to know. Alrighty, so I hope you've seen how z-score works, how you can use it to find both greater than, less than, in between. You can actually go backwards on this idea and find the scores, right? We have a formula now. We have a lot more information than just the normal curve. You have a quiz next class. The sub's going to talk more about the logistics of that, but I highly recommend that you study from these 2 sections. These 2 sections are also posted on your Canvas should you want to review them again. Otherwise, I will see you again in section 3.